So in the last video we talked about the angular motion, the introduction of angular motion in detail. So in this video I will extend the course that I have been teaching about the angular motion, angle motion and not angular motion. Angle motion, angle, that is the motion that is angled to a single plane. So what happens, in the last video I talked about the motion of an object that is displaced or projected at an angle to a surface. So what actually happened in that video is that I explained as to how the velocity can be velocity, since it's a vector, can be decomposed in the horizontal direction and the vertical direction, and how you can understand the velocity, the change in velocity, the change in displacement, and how much time it takes for an object to come to a neutral position. So in this video I will be talking about some general equations that you can derive and explain the motion of an object, what actually happened, what's the path followed by the object in that direction. Alright, so I calculated a simple example in the last video. If you have not watched that video, I invite you to go and watch that video and come back here, and it will be easy for you to understand from the beginning, because if you lose some point it will be hard to continue the process, not for only this video and for the videos that will be coming next. So I invite you to go and watch that video and come back. So if I take the velocity, if I take an object, right, if I take a single plane like this, and if I have an object like this, alright, so if an object is projected with velocity v, that is theta inclined to the horizontal, so this is theta, so this will be theta. So what happens to the object's motion? Alright, I will not consider the object's motion from, I'll take this as A, and I'll take this some point here as B. So A and B are on the same plane, so the vertical displacement will be 0 as discussed in the last video. So I will not take the motion of the object that is going from A to B, because the motion from A to B is just simple horizontal displacement and a vertical displacement. You can find the time. So I have done a simple example in the last video. So I will just take some height achieved by the object at some time t, so that we are taking it as a generalized motion. So if I take the motion from A to a point called C here, now it will be easy for you if I take the horizontal and the vertical directions, or the horizontal or the vertical components, or the horizontal or the vertical coordinates of this point. So I take the positive x-axis along this plane. So this will be positive x-axis, and I will take the vertical axis that is going perpendicular at the point where the object is projected. So this will be y that is going through the center of mass, so that the velocity of the object is at the origin of this coordinate. So A will coincide with the origin. So what actually happens is that I will take a point C on this position here, some point C, some arbitrary point, you don't need the exact length, and I will take the coordinate of this point, the x coordinate of this point as x, and I will take time t equals 0 at A. So within and time t equals t at C. So within time t it moves from A to C in the horizontal direction. Alright? Okay. So it moves at, it takes time t for the object to move from A to C in the horizontal direction. It will have a velocity v, and if I take the horizontal motion, I will take the object to be moving to a position called D here, right? so that the height of this object will be y. Alright, so the exact position of this object will be where the C and the D coordinates meet each other. So this will be some point here, some point here. So the x coordinate at this point will be x and the y coordinate will be y. So if I put s equals ut plus half at squared in the vertical direction, now I don't know what's the displacement of the object. So you can't find t because y is not equal to 0. So in the last example of the last video, I talked about when y is equal to 0, the total motion from A to B, from A to B here on the same horizontal plane. So the y value is not 0, so you can find the value of t in order to find x. But you know that the gravity doesn't act upon the object when it is going in the horizontal direction. Now to find t, you can find x, and you know what is the initial velocity. You can find t if you put s equals ut plus half at squared in the horizontal direction. So considering the motion from, I'll take this point as P. Considering the motion of the object from A to B, I will put s equals ut plus half at squared in the horizontal direction. So A to B, right? A to B, I'll put s equals ut plus half at squared in the horizontal direction. Alright, so the displacement of the object at time t is x from A to z, so s is equal to x equals the horizontal velocity will be this velocity is v, and its decomposition in the horizontal direction will be v cos theta. So u is equal to v cos theta if we put on in the horizontal direction times time t. So since A is equal to 0, half at squared will be 0, so x is equal to v cos theta times t. So you know now the sum is given the value of x, sum is given the value of v and theta, so you know what is x, you know what is v cos theta, but t is the value we have taken. So you can find t by taking x by v cos theta. T is equal to x by v cos theta. Now you know the value of t because x, v and theta are given in this problem. So you can put put s equals ut plus half at squared from A to P in the vertical direction now. So from A to P, s equals ut plus half at squared in the vertical direction. So now you know the vertical coordinate of P is y, so s is equal to y, and the velocity in the vertical direction is v sin theta. Time t you have calculated, and the acceleration will be minus g. So here is v sin theta times x by v cos theta. I will substitute it directly. So half times minus g is minus half g t square, so I will substitute it directly as well. Minus half g t is x by v, so t square is x by v square. X by v equals to the square. So y, you can simplify this further. Y is equal to, so v to v cancel here. V cos theta divided by v sin theta divided by v cos theta is tan theta. So tan theta times x is x tan theta. Minus half times g times x by v cos theta whole thing squared. So that is gx squared divided by 2 times v squared cos squared theta. So that is gx squared by 2 times v square cos square theta. Now you can see, now this is seems to me as a quadratic equation of x, because there's some function, there's some x here, there's some x squared here, and y is a constant. That y is not actually a constant. Y changes according to x, but you can convert this into a type of quadratic function. You can say y equals, right, tan theta times x. I'll take minus g divided by 2 v squared cos squared theta as plus times minus g divided by 2 v squared cos squared theta. So that is plus times, this is minus g divided by 2 v squared cos squared theta times x squared. Alright? Alright. So this is y equals tan theta times x plus minus g times 2v squared cos squared theta times x squared. So this is in the form, so you know that theta is a constant for this angle, theta is a constant for this motion, v is a constant for this motion, and g is a constant for this motion. So if theta is a constant, tan theta will be a constant, and g divided by minus g divided by 2 times v squared cos squared theta will be also a constant. So this is in the form of y equals ax plus bx squared. So this is a very important derivation. Y, if y is in the if some function of x is in the form y equals ax plus bx x squared, this will be a simple parabola. So this is a parabola. So we are actually talking about an object that is moving in a parabolic path. So we call, since this is a motion that is being projected, we call this motion as projected in some direction. We call also this motion the projectile motion, and since the object moves in a parabolic path, we call this as the parabolic motion as well. So we are actually talking about what is meant by the projectile motion and parabolic motion. So welcome to the concept of projectile motion or parabolic motion. So in this video I explained to you the introduction of projectile motion or parabolic motion by taking a simple sum and then finding the value of t and then finding the general equation that and showing that the motion of this object is actually a parabola. So in the next video I will talk to you about the general equations of motion, general equations with general derivations of the about the motion on projectile path, or the projectile motion or the parabolic motion. So see you then, and thanks for watching this video.